The last talk dealt with building a persistent network for community. This talk deals with building a network for an ephemeral community. Ladies and gentlemen, Johnny Diggs, Willow Brew.
So the thing behind us is going to be a little bit clipped, and so I hope you don't judge me on my design skills. I promise I centered everything perfectly. It's technical issues.
It looks really perfect right here.
It does. It's amazing. So we're going to talk to you today about Geeks Without Bounds, which acts as an accelerator for humanitarian projects. We do 1 to 5 hackathons internationally every month, which we usually see as sort of speed dating between people with technical skills or design skills and organizations that could really use their help, either in humanitarian or disaster response. We also support some of those projects and teams through 6 months of mentorship in things like human rights and information security and business development, so that they are responsible not only to themselves but also to the people that they're hoping to help. And the specific thing that we're going to focus on today is what it is to build an open source cell network at Burning Man.
Yeah, it's one of the things that we focus on in addition to crisis response and humanitarian response is communications, because when I founded Geeks Without Bounds with Willow, one of the big things that I was focused on, basically based on my background, is helping people communicate in times of crisis, and that's one of the key things that anytime there's a disaster response team, one of the top priorities is to get comms up right away.
And right now, most of the time when comms are put up by the formal sector, it is for the official responders. They don't consider the first responders to be the people that already live there. And so one of the things that we really like doing is helping to also put up satellite uplinks in disaster zones. That way the people who live in an area can self-organize because they have better access to communications. So, Diggs, do you want to introduce yourself?
Yes.
If it'll work. You know, maybe.
So I'm Johnny Diggs. That's actually my stage name. I'm a professional dueling piano player. So I was encouraged to take a stage name. And so Johnny Diggs seemed to work well. I'm also a co-founder of several technology companies. IRDG, which we founded in '95, which was focused on unified messaging. Voxeo, which is a internet interactive voice response company, and most recently Tropo, which I'm the chief evangelist. I do all of our developer outreach, and Tropo is a over-the-top voice application development platform, and also Geeks Without Bounds with Willow, and I just recently got involved with starting Orlando's first makerspace.
And I am Willow Brew. You'll notice that both of these pictures are from Burning Man, which, of course, that makes sense. I do things with Geeks Without Bounds. I'm also at Center Pacific Media, with the MIT Media Lab, with the Berkman Center for Internet Society. They let me hang out and visit their libraries. It's amazing. I also am working with the Roddenberry Disaster Response Team, where we bring in water filtration systems to disaster zones and help set it up. It pumps through 500 gallons of clean water a day out of any non-salinated water source. And then we leave that stuff behind so that they can set up markets around clean water. And also the Space Federation, which linked together a bunch of hacker and maker spaces, specifically in America. So Black Rock City, where Burning Man happens.
It's basically in the middle of nowhere. Has anybody been to Burning Man before? So, you know, maybe 5%. Closest airport, or closest large airport is Reno, about a 2-hour drive north of Reno, directly into the middle of the desert.
And then, oh, hey, what's up? Sidebar, don't get annoying. And then about 75,000, or not, and then about 70,000 people show up to a place that nothing else is happening, and they set up camp for about a week, and they hang out, and then they all leave with all of their stuff again. We also set things on fire.
Burn, burn.
And we also build lots of weird art.
So yeah, one of the most common misconceptions about Burning Man is that it's a music festival, but there is music there. It's usually a lot of wub wub wub, but dubstep. But there's also live music, but it's not specifically a music event. It's culture. It's about sharing things. It's a dirt rave, but it's also about radical self-reliance. It's about they have these 10 principles, guiding principles of Burning Man, which include everything from that there's not really any exchange of money there. It's more of a gifting economy. You can buy ice and coffee, and that's just about it. But it's also about radical self-reliance, leaving no trace behind, fully participate, being participatory, and also immediacy, which is also very important.
And it's also an experimental wonderland. And in disaster response, it's really difficult to try out new things because usually you have to do whatever you can with what you have right then. And there's no space to really try something because if it goes wrong, things are really bad. But if you suddenly have this influx of a population, it's like a test bed, but nobody cares if you mess up, which is exciting. And this is basically the population of what we call the playa. It's a joking term about the beach because the ground is actually usually a lake it's a lake during the winter and then it all evaporates, and it does that over and over and over, and it ends up with this really alkaline, really fine soil that eats everything, and it gets on all of your plates, and if you're even slightly compulsive, it is the worst thing ever.
Eats all of your electronics.
Yes, and so the population of the playa tends to be zero. There are a few festivals that happen over the summer, and then there's this huge peak that happens right around Labor Day, which is when Burning Man is. And that means that, will you work?
There you go.
The nearby town of Gerlach has a population of 250 people in it.
That's the closest semblance of a town. And Gerlach has a cell phone tower, one lonely cell phone tower, that is designed to support Gerlach, but in more recent years they've pointed that thing towards the playa to support Burning Man. But the problem is that it is one lonely cell phone tower, and when you have a peak of suddenly 70,000 people, you'll notice a decline in service very quickly.
And so we want to know what we can learn from this gap in infrastructure. How can we play with this?
So this is the Burning Man layout is sort of a half circle, and this is sort of a heat map of where we put towers a couple years ago. I don't know how well that's showing up there, but those circles are centered around cell phone towers. So we try obviously to get 100% coverage over Burning Man. This year we got about 70% coverage. And obviously the more towers you put up, the more coverage you can have. Before we get into sort of the details, this has been floating around for a long time. I did not create this, but if you care to understand how your fucking phone works, I suggest looking this Prezi up later on and zooming into some of these because it's really, really funny. I'm not going to go into all the details, but basically your phone connects to a local BTS station, just like the one that they were showing on stage before, and that is connected to a network, and the magic of the phone network finds you and your phone rings, and it's magic. And that's how you get a fucking phone call.
This is what our network looked like.
I'm not going to go too much into the details. There's a link here if you want to get into the really technical details of how, specifically what the connections were like in the network. But we used almost 100% open source software with a couple exceptions. OpenBTS, which is an open source based transceiver station software written by David Burgess and Harvin. And then asterisk we use for database, for phone registrations. Yates stands for yet another telephony engine. And then of course Tropo, which we use to build some simple applications, because without an application platform like Tropo, you wouldn't really be able to do much other than send and receive phone calls. And also Tropo provided a link to let people make outbound phone calls into what they call the default world, which is the world we're living in right now.
These are what those towers actually look
Pretty
like.
pictures of towers. These were all actually set up. We used a variety of different towers. Some of them were portable towers, like the one that is right there. That is actually designed to be set up by one person. Believe me, it can't be set up by one person. We use trucks like news vans to set up some of them, so we can get enough coverage all around in various places. And obviously the higher and more spread out your towers are, the more coverage you're going to be able to have. So here's some data from 2012. I tried to get our 2013 data, but the guy who has it all is in Bucharest right now and didn't respond to me in a timely fashion.
By which we mean this morning when we were making sure everything worked okay.
Love you, David. 2012 we had 5 sites in a variety of different configurations. The end result was we had about 1,100 phones subscribed to the network, and about 8,000 phone calls made to the outside world over the course of the week. With handset requirements, we required that you had an unlocked quad-band GSM phone, which is fairly common outside the U.S. We specifically blocked AT&T SIMs for no other reason than that Lonely Tower over at Gerlach was an AT&T service provider, so we didn't want them. We were running a legal network, we had a license, but we didn't want any insinuation that we were interfering with the commercial network. So we block AT&T phones. And then we also provide SIM cards at our camp, so if you wanted to try it out, you could come and we just give out free SIM cards. And we actually had some free burner phones. These were like...
That was a pun.
Was actually accurate because they're really cheap feature phones that you can get for like $10. That we would pre-configure, and if you didn't want to mess with anything else, we just handed it to you. Asked if you would please bring it back at the end of the week, but we only got a few of those back. A lot of people like to keep them as souvenirs. So inside the network, you could make phone calls to other people who are registered on the network. So when I call that playa to playa, voice calls, you could do playa to playa SMS. We very much limited the ability to make calls inbound, and the way we did that was when your phone registered into the network, when you roamed in, you got a unique 6-digit phone number, so it didn't interfere with your normal 10-digit phone number. And but when you tried to make a phone call out of the network, we did that through Tropo, which went over VoIP, and the receiving caller would see a normal 10-digit caller ID, but it looked like a phone call from coming from Reno, and then if that person answered, you could talk to them. If they didn't answer, they could call back to that number, and for a limited period of time, like 30 minutes, we actually would route that phone call back based on the caller ID back to your 6-digit phone number on the playa. So if you needed to get an answer from someone, they could call you back. But it also prevented your boss from bothering you or anybody else trying to sell you something while you're trying to enjoy Burning Man. So that's kind of how we limited it. We said, after 30 minutes, that connection is burned. You'll see a theme here. And so we also did some other apps via Tropo. which included group messaging, sort of like GroupMe or WhatsApp type stuff. We created an app for voice messaging, so if you wanted to leave a message from other people in your camp, you could leave a message and say, hey, everybody meet at the giant steampunk octopus at 8 o'clock, and then other people would call in and listen to the messages, and just like a voice message board. We also provided text messaging alerts for Exodus. So one of the big challenges anybody who's ever been to Burning Man knows is getting in and getting out. So you've got one road, you go through Gerlach and wind your way in, and then there's a gate where everybody has to go through little security checkpoints. And so you got 70,000 people that are entering in within a short 24, 48-hour window. There's 70,000 people also leave within a short window. So last year we actually set up an app for what they call Exodus. So you could subscribe to it and get a text message, send a text message and find out what the wait time at the gate was. And so if the wait time was 6 hours, you might as well hang out at your camp for a little while before you get in your car, unless you like sitting in your car for 6 hours. And also weather alerts. Last year was one of the first times in a long time they had a severe weather come through right at the end of Burning Man. And so we were able to send a text message out to let people know that a big storm was coming. And they don't let you drive on the playa at all if it's raining, because it eats up the desert. And one of those tenets was leave no trace. So eating up the desert would actually be a trace, I guess.
And this is really interesting. I hope most of you were here for the previous talk, because it was amazing. And the question of how the community decides what the social bounds to be reinforced by the technology are. So can your cell phone call only last for an hour, ensuring that you still go and visit people? A lot of debate happens over whether or not to get on these networks and what appropriate use of them is. And so one of the things that we play around with is not just the technical aspect of what does it look like to set up this infrastructure, but also what is appropriate use. So that was one of the things that bounded whether the time limit on someone being able to call you back and what sorts of things people use the SMS for. They decided on their own, the latter part, but it was interesting to see.
It's been, I would not say that this network, which has been the last 6 or 7 years been part of our camp project, it's not without its controversy. Some people don't think that cell phones have a place on the playa. We actually feel that everybody is responsible for their own equipment, and they can choose to turn their cell phone off or not bring it with them. But we find that a lot of people do actually like to have the ability to communicate. So some of the lessons learned, specifically that opt-in policy I was just talking about, that we don't actually force your phone to connect to our network. You really do have to try, you have to set it up to do that. So if you really want to, you can, but most people don't. And a lot of people, we've had some people that are really, really adamant and like one guy come screaming at us saying that we were ruining his Burning Man experience. We just kind of sit there and go, how? Like, because there's, anyway. So, like I said, it's not without its controversy. Over the course of the last few years, we've learned about the registration process. So, if you've ever roamed into a foreign country, you'll always get a text message that says, welcome to the Netherlands. Voice calls are $17 a minute. And text messages are $5 each. Whereas our message is, welcome to Burning Man Network, voice calls are free and SMS messages are free. And if you would like to join, just respond with yes, and we'll send you your unique 6-digit phone number. And so creating that, it took us a while to figure out. We tried with IVR systems where people had to call in or they had to come to our camp, and we realized that the best way is to do it the way that people are used to seeing it when they roam into a new network. One of the the big lessons we learned a few years ago was one of our engineers was playing around with the network and without really consulting or talking to the rest of us, sent out a text message to everyone on every cell phone that was turned on, that included the AT&T ones, that said, "Welcome to Burning Man. We're your cellular provider. We're located here. If you want to come by and learn about our camp, come visit us." And so so I likened it to a zombie apocalypse because when the rest of us woke up in the morning, there were literally, dozens of people standing there looking up at the tower at our camp with their cell phone, and they look at the tower, and they look at their cell phone, and then, I would walk up to them like, "Hey, friend, how you doing? Can I help you?" And they were like, "I got this message on my phone, and I don't, did you hack into my phone?" And so inevitably, I'd be like, "Well, no." I explained a little bit of what we were doing, and they were like, "Well, it doesn't seem to be working." And I'm like, "Well, do you want it to work, or do you just need to make a phone call?" And 9 times out of 10, they would be like, they'd sit there and think about it. "I kind of just wanted to make a phone call." And so I would point over to this little handset
that is covered in dust,
yeah.
like everything.
Yeah, and I'd be like, "You can just use that phone, just dial whatever number you want to call." And they would be like, "Oh, cool." And the next thing they would do is they go over and pick up the phone, and they'd put it up to their ear, and they'd hear dial tone, and you would be like, "Dial tone," and then they would go to dial a number, and then have to pick up their cell phone again. And look up the number that they needed to dial. But yeah, many of the times people just needed to make a phone call. And for the perfect example, a couple years ago, we had a young guy came to our camp, and he was like, "I hear you guys have cell phone service," and he's like, "I really need to make a phone call." And I did my spiel, do you need your cell phone to work? Do you just need to make a phone call? And he's like, "I just need to make a phone call." And so he gets on the phone, and it's very interesting because this is set up inside one of our tents, and the rest of us are like eating breakfast. So we hear a lot of really difficult conversations because these are people that are at Burning Man, but usually they're making a phone call because they really need to make a phone call. And sometimes it's just people who are just checking on their parents or their kids or their pets or whatever. But this guy, right as he was coming in, got a text message from his mom. He was riding with some other people saying that his brother was in the hospital. And so he wanted to call his mom to find out, "Hey, do I need to come home right now? What is this?" And it turns out his brother just had broken his arm in a motorcycle accident and was fine. So the guy was really relieved that he didn't, first of all, his brother wasn't that hurt. Obviously, was not relieved that his brother broke his arm, but he didn't need to it wasn't that big of an emergency. And so a lot of people came to us with logistical problems like that. And that's kind of leads to what we were talking earlier about the humanitarian aspect of why we kind of spend our time setting up this network in the middle of the desert, because a lot of times we learn things about people's relationship with their phone and communication, but we get to do that in a generally safe environment that isn't an emergency.
And so one of the things about, wow, I totally just skipped over something. That's okay. So when people attend Burning Man, some of them take an entire year to plan, and some of them take a few days to plan and just kind of show up. But people, regardless of that much planning and what they're used to, they still really like the idea of being able to communicate with other people. And so we're going to break from this for just a little bit, and I'm going to tell you about some of the other projects that Geeks Without Bounds does, which are all in an attempt to see what mutual aid at a global scale looks like. What can I, as a fairly pasty person, do to show up somewhere and say, I have certain skills, are they actually useful? to the group here, and also what can I learn, and what do we need to learn. The previous talk again was incredible, and I love the things that we can learn from those communities and those rural networks. It's incredible. So I spent some time in Tanzania recently, which is in East Africa, specifically in Muthinga, which is out in southwestern rural Tanzania. And we were working on water infrastructure. So a whole lot of money has been put into water points, which are basically, if you don't have enough water infrastructure, there are these giant things, they're called gravity points, where there's a very thin pipe that sometimes trickles water into these things, and then someone sits at the tap and they dole out water and they charge people for the water. And a whole lot of these have been installed, and a whole lot of them break, and no one knows where they are and which ones are working, and so people just keep dumping more money into installing more.
What's the statistic of?
I think it's the Tanzanian government says that 60% of Tanzanians have clean drinking water, and that is so not true. And so what we did was we worked with community partners, specifically SNV, for people who had feature phones, because there is good connectivity there, to report when something was broken or fixed, which also assumes that there is, gives a general idea of where it is. From coming to hacker cons and spending time in hacker groups for a long time, insisted that we not be able to link those reports back to the specific user, because if this ends up being used for other reporting of infrastructure, it might not be good if the individual is a link to that report. So if someone reports something is broken, or if using an open source water sensor like out of public labs reports that there's no flow of water, then a water engineer would get an update, or anyone with a wrench would get an update saying, hey, this point is broken, you should go fix it. They go fix it. And then we end up with reports of what's going on, so that people, if the government is not fulfilling their obligation of fixing these water points, which they have money to fix, if they're not doing it, you at least have the documentation that something is going wrong. And also you can see how the water engineers are doing. Are they fulfilling their duty? And we can start to see who is responsible for which points, when it was last broken, when it was fixed, etc. So that's one project. Another project is the Bachao project out of Bangalore, India, which is just a distress application. It uses your cell phone hot button, it updates a list of people that you have pre-described about your last known location, and it also starts auto-uploading via any means available to the phone to a server. And it holds up in court. It's court admissible, and so it's used for incidents mostly of gender-based violence. And there's also something like Mozilla emergency badges, which are, we have this really weird PTSD that's starting to happen around digital response, where people here, and also in activism, digital activism, of people getting all of these like, notifications of how wrong everything is, and oh my God, this thing is flooded, or this thing is on fire, and we don't have food, and we're trapped over here. And you do everything within your power to help them based on where you are, and then you don't hear anything back. And it's really, really damaging to the psyche. And so the idea of this is that while there are many people affected in disaster, and there are many organizations out there that are there to help them, and there are lots of volunteers that are there to help them, what is planned for is often not what people end up doing. And so we have a strong emphasis at GWOBORG, I like to say, of just embracing the messiness, of assuming that people are totally competent at self-organizing so long as you get out of their way. So we just connect people directly so that they can say that someone actually helped them via SMS, and the person gets the notification that they helped them, and it also sets up credentialing that is external to organizations, so that they can take that with them wherever they go. They can just show up in an area and say, I am certified in the following 4 things in this standardly accepted format. And then there's, how are we on time? Oh man. We're pretty good. Sweet. Okay. Yes. Okay, and then there's, I didn't draw this one yet because it's still emerging, funnily enough, Emergent Infrastructure Challenge. So In the same way that there's this sudden influx of people for Burning Man, we see a similar trend only in population influx, not in basically any other way, for refugee camps. And so a large number of people have to leave their homes suddenly, and you have to set up infrastructure for a large influx of people where there hasn't been infrastructure before. And so there are three groups that are really interested in figuring out how to help this out, and I want to figure out how to combine them. So one is Doctors Without Borders has a really great how to set up the sanitation infrastructure in a way that is aware of gender-based violence. So usually people just set up restrooms and then even more awful things continue to happen in an already dire situation. And so they just have a basic, like, here is how you ask questions. You have to have a female translator. Here are the sorts of questions you can ask. Here's how you adhere to it. It's very much based on community design and co-design. And then here's how you deploy that. So that's one section. It's in a PDF format. They just need to be able to transfer it between phones. Like, this is Doctors Without Borders, and they don't have access to good technology. They're pretty good at telemedicine, but not much else. Good people. And then there's also UNHCR realizes that in these camps, they are the bottleneck for information. People will stand outside the offices for most of a day in order to ask a simple question. And they have realized that they're the bottleneck. Like, well, everybody has feature phones and maybe even smartphones, and there's definitely a network in most of these places. So can we just build a collective intelligence platform? Like, is that a wiki? How do we do that? And so they're eager to do this, and with material like what Doctors Without Borders has, we can start to seed these platforms. And then also have, because so much of this is geographically based, and then you have to meet sphere standards, which is minimum requirements to treat people like people in these situations, then you can have the updating mechanism through Tarifa. So, cool projects, we like them, and all of them are accepting help. And we would love your help with them.
Mostly with open source, GitHub stuff, there you can go and see what they need and all that stuff. So it's, if you have some free time and you have the skills, all these projects could use some help.
Yeah. So again, workshop on Saturday with the crew that was just up. Really encourage you to go to that. Leisha, who's also from Geeks Without Bounds and is amazing, and I hope she's in the audience somewhere, she's going to give a talk on Sunday morning about cybersecurity and humanitarian projects. I know that I love being awake at 10 a.m. on Sunday. Actually, I do. I usually wake up really awfully early, but I hope that you will join me here with enthusiasm.
And the last thing, in November 21st through 23rd in Portland, we're going to be doing we're trying something new. We're doing a conference that's combining telephone application developers and hackers with humanitarian response professionals and digital humanitarians, and also art. So should be an interesting conference that we're working on. So if you want to learn more about that, I suggest you follow the Geeks Without Bounds Twitter account, because we don't have a whole lot posted yet.
So that's what we've got. And we have so much time for questions because I'm not used to doing broadcast mode. I like interaction.
So, questions? Yeah, so the question was to elaborate on our licensing procedure. We operated, the FCC has a thing called an experimental license, puts you in a specific frequency zone and power wattage, and as long as you stay within their parameters, and you have to obviously clearly define what you do and where you're doing it. Part of the reason we were able to get that, consistently able to get that, is because of the remote area that we're working in, and also these are all professionals that everyone in our camp, in the Papa Legba camp, are professionals that work specifically in this area. So we like to follow the rules.
Hi, I have two questions. I think they're related. So one is for SMS. Can people SMS to the outside world? And if so, is it with their own number? And then two is how do people discover other people's numbers within the camp? And kind of how do they, because if I say I want to call my friend who I know is on the other side, how do I know what his number is?
Good questions. We did not enable SMS to the outside world. We felt that it wasn't a technical limitation. It was sort of a community limitation. We didn't want people to be sitting there texting their friends all the time. It sort of went against our attempts to limit the ability for people to call back, because if you have a long-running text conversation within 30 minutes, it would just keep that connection alive, and we really didn't want to encourage that much connectivity. But like I said, that was not a technical limitation. We did not have any sort of directory services. Typically you share that by voice. You did have the ability to like call into the message board and leave your numbers, and so if somebody else wanted to call in. And then, once you had other people's numbers, you could create, group texting. So if you wanted to like text out to, 15 people in your camp, you could do that.
So can you just describe how the message board works a little bit?
Say that again?
Can you describe how the message board works a little bit?
The voice message board?
Yeah.
Basically, it was a message board per camp. So you're the first person to join from your camp would set up the message board. There would be a unique message board ID, and so it was like an IVR system. You call in, please enter your camp ID. It's a 6-digit number, and then it would just play like voicemail.
And there's also Center Camp, which is the center of Burning Man, and they have an opt-in registry where you can say like where your camp is and that you specifically as a person are with that camp. And so some people were leaving their phone numbers in their details with full knowledge that anyone looking them up would be able to see that phone number.
Yeah.
Thanks.
I jokingly refer to it as an opt-in-a-con. Opt-in-a-con?
Opt-in-a-con.
Do you think your infrastructure could be used to build distributed sensor networks, specifically gunshot detection?
With the, you're speaking about like say the Tarifa network? I mean, basically, the water point is sort of a distributed sensor network. Is that what you're just?
Specifically, if you could use cell phones to spread out over large territory and then be able to monitor gun violence and to be able to locate.
Yeah, as far as reporting, Tarifa is just a triaging platform. You can report anything. They've also used it for education. If teachers have showed up today or the state of the school or whatever else. And so people could report that they had heard something, and then you could do some triage around that.
But
or like triangulation around it, but it's not running the mic at all times, and so it's not the same thing as what they've had in Oakland.
But do you think of developing an open source phone or using another firmware for an existing phone, for an existing cheap phone, to be able to use it as a reporting node continuously without human involvement?
You could. We don't specifically have any projects on that right now, though.
All right.
Mm-hmm.
Hi, great talk, thank you. I had a question about data on the network. Were there any thoughts about maybe like the same way you don't like text message out of the network, but creating maybe data that's local just to the Burning Man, like some apps or anything?
So we didn't provide any data channel to date. The Burning Man infrastructure, they have an infrastructure team, provides pretty good Wi-Fi coverage, and so if you wanted to get Wi-Fi, you can. You have to be associated with a camp that has applied for it and jumped through all the hoops to make sure you get it. So for that reason, plus some technical limitations and, you know, and just time and effort, we didn't supply any data, and so, you know, we may sometime in the future to do some basic data, but yeah, we focus mostly on voice and SMS.
Okay, thank you.
With your experimental license with the FCC, do they, you know, as a quote regular cell phone network, they have to do all kinds of compliance stuff with 911 and all that stuff? Are you just completely exempt from that stuff?
Yeah, experimental networks are exempt from emergency E911 and regular 911. And we make that very clear that that if there is an emergency, you know, find a Burning Man ranger, or go to, you know, there's plenty of police presence on the playa. So, and they're actually usually very, very good. They're there to make sure that nobody gets hurt. But yeah, we made it abundantly clear that we are not providing commercial service. This is experimental, and for you know, educational purposes.
So what happened if you dialed 911? You had like an interrupt that just said, hey, go find somebody. This isn't going to work.
Yeah, exactly. You got like an automated response.
Hi. How do you handle backhaul between the sites?
I don't really want to go too much into the detail of that, but all of that is explained. If you go to that link that's in this, we'll post the link to this shortly, but to the presentation. But essentially, it was you know, point-to-point connectivity between the different towers.
Thank you.
Yeah, hi. I have a question about one of the other projects that you mentioned briefly, Ba Chow, and I was wondering if you could talk about how that works and maybe if you know about KiteStream, how it compares to that service.
So the Chow is headed up by an amazing woman named Shinmai, who lives in Bangalore, and I don't know any of the technical details about how her project works. I only know how to help get it in front of the news and whatever else. But yes. Yes, will you come stand at the microphone? Leisha is in the audience. This is amazing. I just draw stick figures. I use crayons mostly. I don't know how these things work.
Okay, so the original Bachao project was created at Random Acts of Kindness, excuse me, what, a year and a half ago? The original
Get closer to the mic there.
The original Bachao was created at Random Acts of Kindness about a year and a half ago. It was an Android app that it still exists. The original Android app still exists. And it is, that version is just an Android app with a panic button, like Willow explained. And it just uses, you know, the Android infrastructure basically to send text messages to up to 5 people that you preload and call the police, the local police number, 911 or 111 or whatever your local one is, and upload audio and video according to whatever its connectivity infrastructure at that space at that moment is for use in courts, like you were saying. Bachao has continued to expand what they're doing, though. So now they're doing specific use tools like pendants that look like pendants, that are panic buttons that basically have all that functionality that was on the panic button on your phone can now be had in a pendant. So the other program, I don't actually know. What's it called? Something KiteString, I think. I don't know the functionality of that. I know that there are several other panic button tools out there. When we were doing the mentorship, so I think Bachao graduated from our accelerator program 8 months ago, and At that time, none of the other panic button applications that were available had the streaming piece of it, which was actually, one of the key pieces. It wasn't just that you were asking for help, it was that you actually had evidence, in case this went to court, so that it didn't turn around where they started persecuting and prosecuting the victim. You had proof.
Yeah, one of the cool things was when you hit that panic button, it turns on your microphone and your camera and immediately starts streaming audio and video to the cloud. So even if someone took your phone, the evidence would already be up in the cloud.
So I don't know where you went, but did that answer your question?
I think we're good. Thank you all so much for your attention.
Okay. One quick thing about Burning Man, of course, the big motto there is, of course, piss clear here. 521 is the best thing I can suggest so you have a good conference. For those of you who don't know what that is, those are the bare minimums we suggest. Every night, get 5 hours of sleep, make sure you have 2 square meals a day and 1 shower. A day.
about SSL. Similar to
In case anyone in the room is not fully aware of it, the conference hashtag is hashtag HOPEX. The official Twitter account is, of course, at HopeX as well. With us is Jimio, and he's here to talk about some of the interesting vulnerabilities that have come up through SSL. Please welcome Jimio.
Thank you. Can everybody hear me all right? Yeah, is this house music going to keep going through the talk? I'm cool with it, it can. So yeah, hi, I'm Jim O'Leary, affectionately known to some as Jimmy O. I work at Twitter, and it's an honor. I'm very humbled to have the chance to talk to you, hopefully educate and entertain with some of the things we've learned as we went from rolling out a widespread SSL deployment at Twitter. So it's been a bit of a bumpy ride lately for SSL. The protocol, a number of implementations, all have gotten beaten up pretty badly, even in the mainstream press. So a few of these attacks or vulnerabilities might ring a bell to you. There was Crime, Breach, Beast, Lucky 13, Heartbleed, 3Shake. Basically, you couldn't have an SSL vulnerability without a nifty little name, and making basically like headline news with almost all of these. So, man, bad times all around. But there's something else out there, way more prevalent. It's been around for a longer time, not quite as sexy a name, but get ready for this big animated reveal. Yell it out when you think you know what I'm going to talk about here, please. Exactly, right? HTTP, look at it. There it is, HTTP, Hypertext Transport Protocol. It's all over the internet, and it's a big problem today. So, one thing I love about hacker conferences is that you get people from all walks of life, all different levels of technical ability in one room to learn about some stuff. So this is something for the noobs. If you're super elite, you know this already, but let me break down for you why HTTP is a bad thing. Here you are, you're at Hope, or you're at a coffee shop downstairs, and you want to browse the internet, right? So you're connecting via some free, unencrypted public Wi-Fi to some machine that is probably hosted in the back room or under the espresso machine of this coffee shop. It then connects out over the internet as we know it. So there are a whole bunch of different hops, and who really knows what happens in between the coffee shop and was ultimately us, your destination. So in this case, you can call it Twitter. As we all know, there are a lot of these folks probably here today. I think I saw a guy wearing this hat in the elevator earlier. But there are people out there that might be interested in looking at what you're doing online. So surveillance is a big topic of this conference. And also maybe mucking around with it, having a good time at your expense. The key thing to note is that every hop in this node presents an opportunity for somebody to sniff your traffic, manipulate your traffic, or do something else nasty. Man, this is super funky. But don't just take my word for it, right? So this is a screenshot that has been terribly distorted. It looks fine on my machine, but of Wireshark, right? And what I'm showing here, like this is me in a coffee shop capturing traffic with the promiscuous network card, and looking at the ones and zeros as they fly through the air, assembling them into TCP and then HTTP, and then being able to kind of like click in and jump into what's actually being sent on the wire. So again, this is all super fuzzed and mutated because of the display, but what you'll see here if you dig in is that, this is interesting. It's an HTTP post to a login endpoint with a username, say my username, and a password that I just put, yeah, right. It's not my actual password, but it's flying over the network in clear text. So we've been logging in over SSL for a long time now. A lot of sites, even the worst sites on the internet, don't accept your username and password over HTTP. It was interesting to see the EFF talk not too long ago where there were some sites that still take username and password over HTTP. But for the most part, we kind of got that solved. We're using HTTPS for username and passwords because a lot of people reuse passwords on different sites. So that's good. What is not good is if you log in over HTTPS and then you downgrade people to HTTP, these session cookies are flying around the network in clear text. And so you might not steal anybody's username and password, but you'll be able to sniff out, steal, and play back authentication cookies that are used for logging into a site. So as you probably know, when you log into twitter.com, you type your username and password once. We give you a cookie, your browser holds onto it and sends it up to us every single time you make a request so that we know who you are. In the world of plain text internet traffic, things like this come about. So this is an old screenshot, 2010. This is super old Twitter. I think for the sake of everybody's eyeballs, I'm going to unplug this and plug it back in. And then pray. Oh, alas. Is that even worse than it was before? I'm not sure. But anyways, this is Firesheep. Again, super funked out Firesheep. But it's an HTTP sniffing extension that you can add to your Firefox browser. It'll allow you to, again, smell the ones and zeros as they fly through the air, see who is logging into different websites with HTTP supporting traffic. So this is back in the day, like I said, 2010. If you could see here, there's Twitter, there's Facebook, there's Yahoo Mail, I think there was Hotmail, there's Amazon, and you as a kind of nasty hacker bad guy can just select whichever person that you want to log in as. You don't need to know their username, you don't need to know their password, you just look around, you say that guy looks like an interesting guy to log in as, and you click his name and you're signed into whatever service you want as him. So again, that was 2010, that was back in the day, this is sort of pre-Snowden revelation. But what was nice about Firesheep is that it shone a light on an issue that like existed forever. Like, you don't need Firesheep to do this, you can just use Wireshark and write a script yourself. But Firesheep was kind of the first mainstream adoption and realization that this is a problem, and it's really easy to man-in-the-middle HTTP traffic. So as a result, at Twitter, that was like December 2010 that Firesheep came out. January 2011, we rolled out an option to use HTTPS all the time on your twitter.com sessions. So what we had here is like you would dig into your settings page. We announced it, but in order to use this feature, you had to go into settings and click it. And then from that point forward, you'd be safe while you were logged in from Firesheep type attacks, right? Like once you were authenticated, it was SSL from that point forward and nothing else. That was great. People used it. We ironed out a few bugs in the process, but what kind of sucks is that like you only get the people that dig deeply down into their settings and really care about security. Ideally, we'd be able to protect everybody all the time, and you'd have to go out of your way to do something insecure. So over the course of a few months, we gradually turned up a little knob to make this the default behavior is opt out for HTTPS all the time. So you log in now, and unless you go in and uncheck the box, you get SSL, kind of whether you like it or not. After that, cranking that up to 100% and seeing only a few people opt out, we just took away the option altogether. So we said, all right, if you want to use twitter.com, SSL, tough luck, you're going to get it. It's 2012. So I mentioned that surveillance is something that we all care deeply about here, as is sort of censorship. And so I'm going to sprinkle in a few like wins and good stories that we saw as a result. All right. That looks better, at least. And so that's tough to read. What I want to highlight down here is that there was a situation in India some years ago where a little, political discontent stuff going on, and the government wanted to censor certain Twitter accounts from being accessed. And they did so in a pretty naive way. They gave all the ISPs in the country URLs to say, block these URLs, basically. Don't let anybody visit twitter.com/activist1. What's great about HTTPS, and this has been mentioned before too, is that after the handshake and you make your SSL connection, everything in the URL, so whether it be the path or the query string, is totally blind, or anybody in the middle is totally blind to what that could be. So what people realized is that if they went to a profile for somebody that had been blocked by the government, all they had to do is actually like sign in, and then they would access the site over HTTPS, and then like, hurrah, you get to see the stuff that the government had tried to block. So that was a win. It was really easy, and it made the government look kind of dumb, so it's even better. So one thing to note, and if I don't say this, somebody's going to yell at me from the crowd and say it for me, so I'll get in front of it and mention this now. Even if you have sessions that are 100% SSL all the time, this guy still has a few tricks that he could use to try to steal your cookies. One gift he might have for you is a HTTP embed on one of his pages. It's not on twitter.com. He can send you an email that can contain this HTML tag. And the way browsers work again is that once you get a cookie from a domain, if you don't do anything special with it, it's going to send that cookie to the domain every time you make a request there. So again, if you're signed into twitter.com, you're going to make this fetch and you're going to send your cookie along. Oh no, it's over HTTP, he'd be able to steal it and send it back to us. Unless, of course, you mark your cookies secure. So this is, again, kind of old news. But if I didn't say it, somebody would call out and yell at me. So if only security were always this easy, we just pass down like an option that says, yeah, make it secure. But for a set cookie, that's really the case. Mark it secure, and it won't fly out over the network in clear text. So it was a very gradual process towards getting everything on SSL all the time. For a while, we'd allow you to load http twitter.com. Like I said, all of our authenticated sessions were SSL. Our unauthenticated sessions, we still let you browse the site not logged in over HTTP. So what that means is that you load http twitter.com and you end up with a page like this. This was mentioned again in some of the earlier talks, but how do you know where this post is going to end up when you click sign in, right? Like you put your username and password in there, but there's nothing indicating to you that this is going to go over a secure channel or to some other website that Twitter doesn't even own. So there's an attack that Moxie and Groundspeak popularized along with SSL snip. There's SSL strip, which basically takes the page that has been served up over HTTP and substitutes HTTP links for every HTTPS link that it sees. So in this case, I'll kind of go to Exhibit A, which was this first screenshot, and Exhibit B, which is the second screenshot. One of these has been SSL stripped, the other hasn't, and they look exactly the same, right? So what the point of this slide is that even though we moved everybody over to SSL once they logged in, there was still this window of opportunity for attackers to get you before we get you into a safe space with SSL. So what do we do about that? This is a bit of a motivational image. Again, it would be fantastic if this thing would actually look good when I showed it to you, but to kind of represent the next level shit that we've done that I'm going to talk about here. And you know, most good tech talks have a disclaimer of some sort. You know, I'm not a lawyer, and the disclaimer here is that we did all this stuff, and I'm up here because you can too, and I would like you to do this. So let's take a step back a little bit, a little more handcrafted slide work from me. But say that you are just a Joe user. You hear about this Twitter thing. Ellen tweeted some funny selfie, or Geraldo's taking pictures of himself in the bathroom mirror. You want to find out what Twitter is all about. So you go into your browser and you open your location bar and you just type Twitter. This is kind of a standard interview question for some like networking jobs and stuff like that. So you know what happens when you type Twitter into the location bar. In this case, the user didn't qualify with like a .com or a .net. So actually the default behavior you're going to get is you're going to end up on some browser or some search engine, right? So maybe you use Bing, maybe you use Yahoo, maybe you use Google. And so I'll go back a few slides here. One of these things is not like the other. So first result for Bing Twitter, Yahoo, twitter.com. But Google's URL is https twitter.com. Again, this is before we moved everything over to SSL all the time, logged in or logged out. So what's this crazy magic? How did we pull this one off? You might not be surprised to know that there's a lot of name calling on the internet. And this is like bullies and meanies, or it's DNS and CNAMEs. So we serve up content when you make a request to our servers, and it's possible for people to actually put their domain names in front of our servers, and we can't really do too much about it. So we can detect it when it happens, but there's nothing really stopping you from saying, I'm going to register hopetwitter.com, and I'm going to point it over here, so that when you make a request to hopetwitter.com, it gets looked up and ends up getting content served from our servers. And so this does all sorts of bad things for like the business and for the website. It lets your content get indexed on other domains. It makes people feel comfortable potentially logging into other domains that you don't own. And it's a generally thing that you don't want to have happen. So Google supports this link rel canonical element that you can embed in the HTML on your page, and it lets you as a server that's rendering the content tell a crawler or a search engine bot where this content is authoritatively being served from. So again, we had http twitter.com links out there, we had http twitter.wacky domain stuff out there, but we always served up the content with this hidden tag in there that told the crawlers that no matter how you got to this site, index it as if it came from https twitter.com. So as a result of that, we saw the HTTPS URL kind of jump up the chain in the search engine results. And what's nice, the big defense against SSL strip is never letting people try to access your site over HTTP in the first place, right? So if you do an encrypted web search, you're on HTTPS google.com, and then the link that you click is to HTTPS twitter.com, no HTTP request is happening there, no SSL strip, no SSL sniff, great win. So that was fantastic. I mentioned this, like, again, this is kind of old news for us, but not a lot of people do it, so that's why I want to tell people about it. It's one line of code, and you can index your content with a secure link. There was a blog post that somebody pointed out to me from some of these like search engine optimization folks that said this is actually a bad thing to do. You're going to confuse the crawlers and you're going to end up with negative results when it comes to your URL getting indexed. And so I think that we saw this maybe that it took a little while for the HTTPS URL to creep up to the top, but it's not like we lost credibility in the process. And so one little funny aside again, is that any web hackers in the audience know what this URL encoded value is? That's right. So I was doing something where I was, maybe some directory traversal attack where I was like, yeah, what was the URL encoding for slash again? So you hit up Google and you just do q equals %2f because you're like, let me check this out. Funny enough, the #1 search result for slash is like slash on Twitter, and it's an HTTPS site. So rock and roll, everybody wins, secure, and all the better. So Bing and Yahoo, these dudes are still loading the page over HTTP. What gives? They say that in order to be indexed over HTTPS, you need to respond with a 301, which is a HTTP response code telling the crawler or anybody that visits this site, no, we permanently moved this resource to this HTTPS URL over here. So we were like, okay, 301 redirects are coming up, freshly served from our front end to you, the user. Anytime you load HTTP twitter.com, you're going over to HTTPS. It took a little while for them to catch up. Literally a pretty long time. Our search results are still HTTP twitter.com on Bing, still HTTP twitter.com on Yahoo, or HTTP twitter.com on Yahoo. What's the deal here? So eventually, after some time, I'd given versions of this exact talk at smaller like B-sides conferences in Seattle and San Francisco. And before I updated my slides for Hope, I was like, let me just go back. Hopefully by now, we're indexed as HTTPS somewhere. So Bing caught up. Now we're HTTPS twitter.com on the front page of Bing when you look. All right, we're almost there. Yahoo was still HTTP, so this was a bummer. What I did actually recently while I was preparing for this talk is email the chief security officer of Yahoo and was like, this isn't a threat. I'm about to give this talk in a few weeks, and I've noticed that we've been serving up this 301 redirect for like a year plus now, and we're still indexed as HTTP. As a result, now we're indexed as HTTPS twitter.com. And so that was an effective way to get us basically linked as the #1 search result for Twitter with HTTPS URL. So that's nice. If you're trying to find Twitter through a search engine because you don't know that you should probably just do this, then you're protected. Which brings me to this next point, is if you're a little more tech savvy and you type twitter.com into your browser because you think that's where Twitter might live, are you actually less secure than you might be if you were coming to us via a search engine? And you would think yes, right? Like by default, the browser behavior is to try HTTP first. So you type twitter.com, it's going to make an outbound HTTP twitter.com request. It'll get the 301 and then it'll send you to HTTPS. But that gives the attackers that are man-in-the-middling us an opportunity to basically never send us to SSL version of Twitter at all, and to basically perform SSL strip attacks and steal our cookies and steal our passwords and all that stuff. So I wouldn't be telling you about this if we didn't do something to address this issue as well. And so an opportunity for you to play along at home if you want is type twitter.com into Chrome or Firefox. And you'll notice this behavior. So open up Wireshark if you want, or open up the network tab in the developer tools, and you'll see that you get a redirect. Oh my God, it looks terrible up there. But you'll get a redirect that happens locally before ever hitting the network. And so if you could see this, there's this arrow pointing down here that says twitter.com pending, and then a redirect over there to https twitter.com. So the browser did try to load the resource over HTTP, but it itself knew, no, we're going to go SSL before we actually make this outbound request. And what is this all about? The HSTS header has been mentioned a few times today, but HTTP strict transport security is a header that you can set down when you visit a site over SSL that tells the browser, kind of like, oh, phew, you made it here over SSL. Let's never go back to that scary place of plain text HTTP traffic ever again. So from this point forward, until this max age expires, which is basically 20 years in this case, if you ever get an HTTP twitter.com reference, turn it to HTTPS locally on the client before you do anything else. So this is fantastic. It actually defeats SSL strip, basically. And so it's funny, you know, Moxie, the author of SSL strip, he worked at Twitter for a little while. Super legit dude. He was my boss. He's a really cool guy. But it's not as if we got defense against SSL strip by hiring the author and then telling him to make it not work against Twitter anymore, which some people thought we did. We actually just use the HSTS header. And so you too can protect against SSL strip without hiring the author, and just send down this header. It's one line in your Apache config or whatever, and you're all set. Even better than HSTS is the ability to preload HSTS into the browsers themselves. So let's say that you've never been to twitter.com and you never got redirected to SSL and you never got the HSTS header. It's basically physically impossible unless you modify the binary to load http twitter.com in Chrome. And that's because, similar to emailing the CSO at Yahoo and being like, hey dude, let's get the SSL over here. You can email Adam Langley, he's probably here somewhere maybe, or some developers on the Chrome team, and kind of pre-cook HSTS into the browser. So Chrome started doing this first. Firefox has picked up their list and started doing it as well. All you have to do is tell them that, yeah, we don't want people to ever visit HTTP resources using your browser ever. So if you load twitter.com, like I said, in a fresh install that's never been on the network before, you type in http twitter.com, it's going out over SSL, it's getting redirected locally before it hits the network. Again, no SSL strip, cooked into the clients. This is awesome. So we rolled all this stuff out gradually and measured some things, but didn't really like keep a super close ID on it and just like flip the switch all at once. We were pretty gradual in rolling out both opt-out SSL and basically removing the ability to opt-out SSL. All these things happened kind of gradually. We had the luxury then, after we knew that it worked, to flip the switch on some of our subdomains that are not on the twitter.com domain and then monitor what happens. So this particular graph shows kind of the trend. It looks like somebody's dying here or something, but what we're counting is the number of HTTP to HTTPS redirects we're doing when you load web.tweetdeck.com. So what would happen is you would type in, I want to use the TweetDeck web client, and we would say, oh, you hit us over HTTP, you need to go to SSL instead. What's apparent here is when we started setting the HSTS header, because the number of HTTP requests we got to this domain dropped off almost entirely. So granted, about a third of the traffic maybe still came to us over HTTP, and that's because this happened back in the day when not every browser supported HSTS. I think IE still doesn't, but is going to do it soon. But so this is not like people stopped using the site, they just stopped using the site in a way that would make them susceptible to SSL strip attacks. So this is great to see in practice. We were like, yeah, it worked, awesome. And kind of gave us this mantra that we abide by inside Twitter. So if you join Twitter engineering, and on your third day you hear me or somebody from my team give a talk about writing secure code at Twitter and all the things we do, and this is a slide we pull from the new hire orientation deck. We jam it down your throat on day one, and it's like a fantastic law to abide by. And again, I'm here to tell more people to do the same thing. There's an earlier kind of jab. It's like, come on, everybody, it's 2014. We can use HTTPS. But when you do, once you start living by this mantra, it's still possible for you to make mistakes or other people to kind of make mistakes on your behalf and affect the integrity of your SSL implementation. So this little dude, the yellow lock, the broken lock, is an indicator that somebody's done something wrong with your SSL content that's been loaded up, and it's probably the developers. And so what we use as a little trick is content security policy. So this is something that I'm not aware of many other people doing, and again, I hope more people take from this talk and start doing. Get ready for a super busy slide that is going to be super tough to read. But this is a CSP header that we send down with some of the content that you load, and I'll walk through it a little bit to tell you what's happening here. So similar to how HSTS tells the browser that, oh, great, you connected over HTTPS, let's never go back to HTTP again. CSP tells the browser, okay, fine, here's all these resources that you load. Now here's some stuff not to do with the code that we just gave you. So it starts off, the HTTP header, content security policy. After that, we use a whole bunch of different directives, but you can tell what we're trying to accomplish here is, like, if you want to load some content, it needs to start with the HTTPS protocol. The iframes that we load on our site, okay, they need to start with HTTPS, whatever. We're not enforcing that all the content needs to come from twitter.com. You can see there's a couple examples here where, in order to be backwards compatible with some stuff, we allowed a few HTTP connections. But what is nice about this is that if you have it in just default mode, which is content security policy, the browser is actually going to block any case where we messed up. Like, it's going to say, oh, it looks like the developers include an HTTP link or HTTP, not a link, but HTTP resource in this page. I'm just not going to load it. And what's great is it will notice it as developers because things break when we do the wrong thing. Even better than that is that CSP has a support for a report URI directive. And so when one of these violations happen, the browser is actually going to make a post back to a URL that we specify in the header, and it's going to tell us, we did something wrong. When we tried to load this page and something that we told it to not do was done. And so we have some basically real-time aggregation stuff going on. We can basically tell if we shipped a bug to production, oh no, this thing slipped out, and we have the HTTP resource. Let's fix that up in the next deploy and get everything back to the nice green lock. So use CSP for a number of things. It's traditionally thought of as cross-site scripting mitigation, but you can use it for getting and detecting any usage of HTTP on your HTTPS site. So it's great. It's also tough to apply uniformly across all your different properties in the same way all the time. And we have HSTS, we have content security policy. There are all these other headers that you should send down as well to tell the browser not to mess up this stuff that you're trying to display. And so we created a library that we've open sourced. It's up on GitHub. It basically does the right thing by default. So I mentioned earlier with the SSL all the time on twitter.com how it was crucial for us to make the right thing happen by default and not rely on our users going in and checking the checkbox. Same thing with our developers at Twitter. We want them to use this library. It's been ported to Go and all these different languages. If you visit this site, we have links to the other languages it's been ported to. But for developers too, we just want you to do the right thing without having to think about it. So this library is out there. Please contribute to it. Please use it. Check it out. It'll do all this stuff for you without thinking about it. Another good way to detect when you might make a mistake is just to make things break hard when you do. So after we moved the whole HTTP twitter.com site to HTTPS, we still had the platform to worry about, right? Our clients connect to us over api.twitter.com. A lot of our third-party partners connect to us over api.twitter.com, which was sort of a longer tail to fix because we have partners that, we can't just say, okay, boom, HTTPS now for everybody and get ready for it. So what we did there is kind of gradually tell people about it, tell the developers that we're going to move api.twitter.com to SSL all the time, get ready for it. And we ran a series of blackout tests, you might call it, where the way you might notice that we've made this change is that your app just breaks and it stops working. And so in order to be kind of nice to people, we say, okay, we're going to turn off HTTP for an hour on this day. Everything's going to break if you're not over on SSL yet. And people that aren't paying attention to our mailing list and stuff are going to be like, oh, what the heck happened? My thing stopped working. And then they're going to yell at us about it. And we're going to say, yeah, we were running this test. So just add an S to your HTTP api.twitter.com URL, and then you'll be all set. So we did this over the course of a few months, and then Now, the API.twitter.com endpoint will basically return this error if you try to use HTTP. So this is great because not everybody uses HTTPS Twitter.com. Like I said, we have third-party clients. We've got our own native clients. But everybody there now is using SSL all the time because the server enforces it. So this is great. There's all the ways you can mess up. There are a number of documented situations where somebody else messes up SSL for you. So there is the TLS protocol itself, and there's a dependency on the certificate authorities, and trust needs to come from somewhere. So there's this paper, there's this incriminating slide that names a number of folks that have been involved in one way or another in subverting the trust model that TLS depends on. But basically, you need to get the trust that you're talking to, who you think you're talking to, from somewhere, and that's where certificate pinning comes in. So again, this is something that not everybody's doing. I think Trevor's in the audience somewhere. This isn't actually a certificate pinning image. I stole it from the TAC website. But the way pinning works is that you rely on the operating system, so the code beneath you, to do all the things that normally happen during SSL handshake. So check out the certificate that you got. Does it match the host name? Is it expired? Has it been revoked? Do all that kind of stuff that you normally do. Then, when you're in app land, check out the certificate that was actually used as part of this SSL handshake. So what you can do if you own the client code, and we do this in like Twitter for iOS and Twitter for Android, Chrome actually does it for us too, is that we check against the pinned routes. So we say, we know that we're only ever going to buy certificates from these 3 CAs. And if you get a certificate that came from Turk Trust or the Indian government, something's up. Even though this is a certificate you would normally trust, how about you don't trust it in this twitter.com session? And after that, everything else works. It's just kind of like on bootstrapping the SSL connection that you implement the certificate pinning, and nothing else really needs to change in your application. So OWASP, I think, has a great wiki page on implementing cert pinning in your own applications, and so go check that out. It's a little more detailed than I can get to in slides for sure. Of course, security is a cat and mouse game. We rolled out certificate pinning, and then next year, Black Hat, this talk comes out about getting around certificate pinning. And so the thing I want to stress when it comes to pinning is that the threat we're trying to protect against and the adversary in this situation isn't you yourself with your jailbroken iPhone. So these attacks, while they work, they basically rooted your device, hooked some DLLs, and then modified the way in which the code was running on the client so that it could get around pinning. So this is good if you want to like pen test Twitter, or you're scared that we're sending some information off your device that you don't want us to send and you want to man in the middle it. That's cool, like do your thing, intercept the way, but what we don't want to have happen is basically on that first diagram where we have all these hops along the way in between you and us. We don't want anybody there messing with the traffic. So if you want to mess with your own local instance of the application running, go to town, go nuts. That's not the threat we're defending against with pinning. What we want to stop is anybody that's got their hands on a certificate that wasn't us, and detecting that. Unfortunately, step 1 there was rely on the operating system for the first part of the handshake. And this is a slide that I did update this year. This might ring a bell to some folks, but Apple had a kind of nasty bug that came from this like second conditional not really being conditional and always jumping down here. Adam Langley, again, being a super legit and super smart guy, has a way better write-up than I could talk through on stage at his blog. Check that out. But basically, if you're relying on the OS for some part of the handshake and you're not doing it yourself, you can be susceptible to the underlying problems in that code. So Twitter for iOS was affected by go-to-fail, but we also inherited the patch as soon as iOS patched. So we could go many steps further than that, but you need to take a reliance on the operating system at some point. Like, we're not going to implement our own full HTTP stack and write all our own TLS code. Like, at some point you need to draw the line. Pinning is going a lot deeper than most people do, but it still opens up to this kind of problem. So perfect forward secrecy has been getting a lot of attention lately, and kind of rightfully so. I prefer the term forward secrecy. Perfect is, I've been in security for too long to call anything perfect, but it can be super easy for you to implement if you're just running like your own web server and you're not trying to do everything with like massive scale and TLS session or something. Basically, you can go to Mozilla's page for like setting up a secure web server, copy and paste the recommended Cypress suite list that they have for you to implement, and just put that into your HTTP config and restart your server, and boom, you've got PFS Cypress suites to the top of the list, and everything that's negotiated from that point forward will use perfect forward secrecy, it'll use ECTHE, and knock yourself out. If somebody steals your keys, they can't go back and decrypt all the traffic that they maybe captured in their mass surveillance efforts. So forward secrecy is great. We have this blog post because, again, Adam Langley has a blog post about how you can botch forward secrecy if you're using TLS session resumption, which you might want to use for performance reasons. So we have this post about how you can encrypt your tickets and share them all. Again, check it out because it's a lot more detailed than I can get into here. I think Jacob, who wrote this post and is now at EFF, is here somewhere. He's a cool dude. I think he might be talking somewhere, but if you see him, say what's up and say thanks for the forward secrecy on Twitter. So Heartbleed happens as well. And so sometimes you're good and sometimes you're lucky. And so Twitter in this case got kind of lucky. Our stack is such that there's code that runs before you get to the OpenSSL library. It was essentially too dumb to pass along the heartbeat request. And so even if we were running, which we were, vulnerable versions of OpenSSL, the exploit couldn't get to the OpenSSL code, and we were like, oh my God, we got super lucky. But all that being said, we rekeyed, we patched the OpenSSL version and all that, and it was the thing that I would like to take away from Heartbleed and pass along to all of you is that it's really good to get good at patching OpenSSL these days from an operational perspective, right? CCS injection happened, I don't know, like a month and a half later or something, and we learned a whole bunch during Heartbleed. It's like, oh my God, we have servers over there? They're running what version of SSL? And over the course of like a few days, we kind of got our act together in, that's harsh. Our entire act together. Stuff was patched super quickly on anything that really, really mattered, but we got to operationalize patching OpenSSL really pretty good by the time the CCS injection came around. And so it would be silly to assume that that was the last OpenSSL bug, and now we've got it all figured out. So you should, again, practice. Even if there's no CVE that came out against OpenSSL, why don't you go ahead and just pretend there were, restart all your servers, make sure everything's cool, and you can still resume your sessions, nothing breaks, and just go ahead and practice as if Heartbleed 2 is right around the corner, because it probably is. And with that, I know I've covered a whole bunch. I've got time for questions. And when I give this talk, this is normally the first question, so I wanted to get in front of it and also bring back one of my favorite memes, which is kind of died off on the internet. But what about performance? And so what I can say, and this has been documented in other places now too, is that Twitter is faster now, significantly faster, once we move to HTTPS all the time. And there is no way that your code up and down the stack on the client and on the server is so finely tuned that the one thing that you can do to shave off a few milliseconds here and there is use HTTP. So you kind of just treat it as a non-compromised issue and say, that's it, we're using transport layer security all the time, and find other places for you to speed things up, and you will, and you'll get much better gains than you might if you just focus on even just tweaking your TLS implementation the whole time. You'll find more lucrative spots in your code base to fix things up. And with that, I know I ended a little early. I think I've got 10 or 20 minutes left. But this wasn't just the whole pitch to say, oh, come work at Twitter, awesome. But you can if you want, because we got a lot of security jobs open. But basically, like I said, this is a whole bunch of stuff we did that happened under the hood, and unless you're super into security and you're sniffing all your traffic all the time, you might not notice that we did it. And that in itself is kind of a good thing, because we changed a lot of what was happening underneath the hood, and people didn't notice, things didn't break. And so if we can do it at Twitter, which is humongous, we've got a ton of traffic, coming in and out of this place, you can do it on your site too, and you should do so. And that's it. Thank you.
So you mentioned a couple things that involve revocation of certificates. So like Harpley is a good example. What are you guys doing for revocation? Are you using OCSP stapling, using live OCSP, or are you just relying on CRL sets in Chrome?
Yeah, so revocation, we do nothing fancy for revocation. There was talk about OCSP stapling, and a lot of people push that. We've experimented with it and just haven't implemented it fully. So basically, same thing for pinning and all that. We just rely on the OS, we rely on the browsers, and kind of have it be up to them. So if they want to use CRLs, they use CRLs. If they want to use OCSP, use OCSP, but we don't do anything special. Light is killing me. And I'll be around. There are a bunch of other tweeps here. Jan up in the front row. Isabella. Jade, you're relatively new, right? Oh, that's right. I've been on Skype with you before. So, yeah, what's up? Like I said, I can't see anything. I'm completely blind.
For certificate pinning,
yep.
You said you insert like 3 service providers.
Yeah.
Can you talk about maybe the economics of lock-in?
Economics of what?
Lock-in to your.
Oh, yeah. So, the question was that I mentioned that we pin to basically like 3 different root certificates, and what are the economic implications of doing so? So you're right that there's a little bit of a good faith in there that says like, okay, now that we've pinned to VeriSign is going to say, oh, time to renew the certs, huh? $400 million because we're pinned in that way. Dr. Evil and whatnot. But so the reason we have multiple is basically in the case where somebody does stick it to us, potentially, we can have a little bit of agility. And we can also upgrade the clients over time to change out any routes if we need to do that. And then the multiple certs are there as well as kind of like defense in depth. So say that we rely on VeriSign issues a bad certificate and we need to revoke that, we can fall back to one of the other 2. One thing to note about pinning, and we've seen bad pinning implementations happen for sure, where people pin against the leaf certificate. So this is a certificate that expires every year, and when April rolls around, all of a sudden, all of these clients, I won't name any names, stop working because they pinned to basically a SHA hash of the leaf cert when you should pin to the root. So that's a little gotcha for anybody implementing their own pinning.
Hey, follow up to that one. Why do you pin to roots rather than using an intermediate offline signing key for yourself?
Yeah, so it's kind of just the ease of implementation, I think. You're right that we could just roll out our own entire basically API endpoint that's signed by ourselves. We could run our own CA. This is sort of easy because you get a bit of the best of both worlds. You can serve up normal traffic to normal people with their own root store, and they can trust us because they trust the CAs versus like doing an intermediate cert on the side. So there's a TAC proposal which is out there which allows for this kind of thing. It's been a while since I've looked at the proposal, but it was something that Moxie and Trevor worked on. We're for it. We just need more like browsers to pick it up too, right? There's kind of takes 2 to tango kind of thing, right? Like you need the client and the server to agree on it. And so we just need some more adoption. And we look at it, but without something like that, we just kind of like use something that we can use most widely. Thanks. I can't tell if, yeah, what's up?
You deal a lot with ads and advertisements.
Mm-hmm.
Do you force your clients to use SSL links?
Not SSL links, right? Because we don't want every person that wants to share a link on Twitter to have to like register SSL for their domain. So what we do.
But they lose the referral if you jump from HTTPS to HTTP.
Exactly. So there was some talk earlier on. So we run TCO, which is our own link shortening service, and what we do for like our kind of our TCO policy is if you tweet an HTTP link, so http hope.net, we'll give you an HTTP t.co shortened version of the URL. And so there was some talk about like, oh, we should just use SSL all the time on TCO. And in that case, you would lose some of the refer information, and people would get kind of bummed out about that. And it's just unnecessary overhead for us in a ways, because you end up on an HTTP URL anyway. So you tweet an HTTP link, and then we move it to SSL, but then we redirect you back to HTTP. We don't really gain too much about that. And sorry, I didn't repeat the question there, but it was like, do you force advertisers to use HTTPS links on Twitter? No, because of that. If you're like a first-party ad server, we're moving more and more. So, I mean, we run our own ad network too, but if you want to embed some ad content, we're putting we are actively moving our partners over to SSL all the time. Yep.
You mentioned 3 CAs that you trust. Which 3 do you trust?
I think it's Digicert. Everybody kind of becomes VeriSign, and that can be a problem.
Not everybody.
Yeah, sure. Yeah. There was talking some of the other talks. There was questions about how do I get a cert if I want to do this on my own website. Startcom came up a whole bunch, and I think GlobalSign issues certs for free to nonprofits. So that's an option too. I use Startcom on my own personal domain. But if you've got a .org or something like that, check out GlobalSign too. It might be a little easier. Because Startcom can be difficult to use sometimes. It took me a while to get my cert, actually. And DNSSEC, so I don't know. It's probably not next. I could say, no, it's not next. We'll do more before we do DNSSEC, for sure. And I think that DNSSEC, I'm not an expert in this domain at all. It just needs to get figured out a little bit more, in my opinion. More or less. No, it's not a terribly satisfying answer, but no, it's not next. What is next? So I think that moving, like I said, we've got Twitter in pretty good shape. We've got some of our like acquisitions and stuff in pretty good shape. I think just getting everything SSL all the time, like moved up the stack is the best we can do, and there's some neat stuff we can do with OpenSSL to get a little bit better and more aware of the cipher suites we pick, depending on what protocol you negotiate with us.
So talking of OpenSSL, you said you're really good at patching it.
Yeah.
Wouldn't it be even better not to have to patch it by fixing the issues before they become problems?
What was the last piece of that?
By fixing issues before they become problems, like by contributing to the maintenance of OpenSSL?
Oh, sure, yeah. I mean, for sure, like, yeah, they're not to contribute to OpenSSL. I think that you need to know that somebody's going to find a bug, even if it's like an open source contributor. Like, there's going to be a patch for something at some point. You should just keep your versions of the code up to date and get good at like operationalizing it, right? So I work in the application side of things. I write code and all this. We need the ops folks that actually like restart the servers and get the keys and all this kind of stuff to get good. I think that's it. Around. Thank you for your time. Peace out.